Hello, here we are again. Chapter 10, Lesson 6. Valve Identification and Numbering. Valve is an important control tool in flow line. Good understanding of the plant control philosophy is necessary. Valve identification types and function. Valves are mechanisms or electro appliances that are used to convey and control flow in process line. In the P&IDs, valve helps to answer some of the following as it affects flow in a process plant. What type of valve is being represented in the P&ID diagram? What is the state of the valve position? Is it lock, close? Is it lock, open? Is it full bore? Is it fully closed? And so on. For illustration purpose, here we have some example of some valve symbols and so on and so forth. This is just for illustration purpose. State of valve positioning. This system provides means of ensuring that valves maintain a desired and safety position during normal operation and are not controlled wrongly. LO stands for lock open and SC stands for lock close. Is it lock close? Is it lock open? Is it full bore? Is it full close? And so on. Consider this diagram and extract just for illustration purpose. Take a look at the state of valve positioning here. Here we have lock open. Here we have full bore, and at the same time lock close. Here we have full close. Isolated and bypass of valves. Isolation valves are on-off valves installed in a series of pipes that allow the flow and stop of flow when open or stop, and they are block valves. For illustration purposes, figure 10.6.3.1 A to F show methods of valve bypassing under different conditions. The A, we have just the ordinary bypass. B, we have the bleed. C, we have dual block and bleed. Then we have spectacle blind in D and spec break. For illustration of isolated system, valve bypassing can follow any of the method illustrated below. Here we have a typical bypass valve. Valve installed in a bypass line represent bypass valve. Pipe is bypassed to allow for continuation of operation during replacement or during maintenance or services. Take a look at this example. We have a bypass. This is a bypass valve. We can consider this as a main line and this as a bypass line in a selected condition. Here again we have a bypass and we have a control valve at the top. In this scenario we have another form of bypass. A bleed can be referred to as manifold valve or block and bleed combine one or more block isolated valve. In this valve, we have our control valve here, typically a reducer, and a block valve. Here we have a bleed valve, though we also have a bypass behind the control valve. A double or dual block and bleed. For illustration purpose, we have the double or dual block and bleed allow the cavity of a valve body to drain that pressure if necessary, and also shut out pressure if need be. Here we have point to point isolated. We have our bleed here, then double block and bleed for process system isolation and for intervention. We have a block, then we have a bleed in between them. This type of drawing is what we call double or dual block and bleed. We have the spectacle blind. Spectacle blind, unlike valve, is a steel dish divided into two plates of thickness, open or closed, and is installed in between flanges to shut down pipeline during repair, for example during overhaul. A typical example of illustration is what we have here. Here we have a spectacle blind installed between these two flanges, though we have a bleed here for points to be isolated. Here we have a spectacle blind open. The single block and bleed valves are used to achieve positive isolation during maintenance in process plant as well. Then we have a spec break here. Spec break show where a specification alteration has occurred on a piping connection. In this place, take a look at the bypass, and we have a spectacle plug. This is where we have the spec break, showing where specification alteration has occurred on piping connection. Here we have another spec break and a spec break here. We have a typical illustration of isolated system. Isolation of control valve having a bypass. The isolation of control valve having a bypass where tight short of bypass is required. We have a spec break here. Then we have our control valve. Then we have our block valve and our bypass line. Then we have our bleed here. Vent and drain. A vent is generally used to remove air bubble or non-condensable gases from process unit, and a drain is used to remove condensate or liquid from process unit. For illustration purpose, we have this drawing here that is showing a drain, as you can see, then a vent. Then relief valve configuration. For illustration purpose, we have a release valve configuration. We have different type of relief valve. The relief valve here signifying the relief header, as we can see in the diagrams. I leave you here with some quick exercises. See you again in lesson 7.